Hello, my name is Salim Dababne, and this is my presentation on our code project, Secrets of the Sea, for our course CIT 260, which is the Intro to Object-Oriented Programming. Our professor this semester was Dr. Aaron Wester, and rather than showing you a PowerPoint, we're actually just going to dive right into code and show you what we've been working on and what's been accomplished in our program. So first off, I'm going to start by addressing some of the items from the presentation rubric. We've been asked to kind of highlight some of the differences between a static variable, non-static variable. So I'm going to start by jumping over into one of our classes here, the current status class. For the game, we have a static variable called statue count. Really, the objective of this game is to actually go and collect a number of different statues from the Bering Seas, and each island will have a statue on the island with the leader for that actual island. And so the statue count as the player progresses through the game will increase, but it's a static variable that's used throughout the game, and no matter where it's called from in the game, it will hold the same value. A non-static variable example is looking at that list of our NPCs, non-player characters. So these would be the individuals you come across as you go throughout the game. We have an example here that's within an enum of our society NPCs, and in here we have different characters that you may encounter. So depending on which island you actually land on, a different NPC would come forward. But the variables, the description, the trust level, the persuasion, the effective persuasion for that particular society NPC will vary as you get to each island, so the code will hold different values for that. Different functions that you may call throughout the game could also be static and non-static. When calling a static function, it requires that you use the class name dot static variable name. An example of that would be in our map.java class. We've got the public static grid, and then if I go into the map control and look for the actual grid piece, go through here where we actually build out the grid based on when we're populating the actual map based on those variables that we need to set, a temp x and a temp y, which then basically builds how large the map's going to be for us in the game. And so that's our populate map control will actually feed back to the information on basically what that grid will look like. So then we can display a map to the end users that varies in size based on a difficulty level. Okay. Throughout the game, we've utilized different arrays, array lists, and enums. And so as we go through the game, when you're using an enum, it's really a big list of constants, going back kind of to the society NPCs. These are constant items for each individual society NPC. And so this is a place where we can use an enum for the code. The array list items, we have our ship control in our game, and in the ship selection control, in here we have an array list that we're using for the ship control to define the different selected ships that the user is going to go through and actually use. And so we use an array list of the different attributes for the ships that are in the game. Basic for statements and using an index within a for statement are some of the things we learned about this semester. And so in our map control, we've got this another segment of our code called the move resource usage. What that has to do with is, as a player is navigating through the game, we're essentially going to take away some of their resources, their food, their water, as the crew is traveling on the seas, we want to make sure they're fed, obviously, keep their morale high. And so, depending on the type of ship a user selects, there's a variable that will change depending on that ship type, and those values will be taken away. So if they're in a certain vehicle where the speed level is high, then the food and water won't go down as quickly as if they were in a ship that moves a little slower. Then they're going to lose food more frequently. Essentially, as they travel from one space to the next, it's going to take them a longer time, so they're going to require more resources. Okay. In our explorable areas control, another example here is our setup areas. And here's where we use a for with an index. And so in this one, we've got the for if, and then basically you get a description on the various areas, trying to define where the explorable areas are, where you're at. And so we'll set, based on your location, the different resources that would be available to you. And so if you're already set at a place where it's a 1, 2, or 3, then we're going to do some other variables. We're basically going to set a description, and then we're going to use an area name generator, whereas area 0, which is the first location, is always going to be the dock at each island. Whereas, again, 1, 2, and 3 are going to be those variable ones that change depending on which island you're on, and we're going to have this generator that actually goes through and changes that, so every island is different. You don't get the same thing. And the area name generator actually has a variety of places to pull from, even though it's going to, for each island, only populate 3, a 1, 2, and 3 location. It's got a list of a few different places to pull from for that list. Okay. Now, as we went throughout the semester, we worked on also doing the try, catch, and throw. And what this has to do is really just error handling. One thing at my work, a lot of the engineers talk about graceful handling. So when a user encounters an error, when the code runs into an error, you want the program to communicate effectively with the end user, to not completely just stop operating, to try and gracefully manage the error. And so the try catch is really an excellent way to do this. And this is something that they often stress at my place of work with code, is making sure there's always a try catch in there. And so in the exchange view area, under our do action, this is a function we use throughout the game, where basically, based on the user entry, we're going to go ahead and update a value and then move on to the various different functions. And so in here we have a try catch. So we first are going to try the various statements in the switch, and then if there's any sort of an item that doesn't get returned, then it will throw this car input exception, or the character input exception, and it's going to go ahead and throw that to the user. The catch is then going to check for the exception and do a display to the end user of the error message, and also write it to our log that we've worked on. And so that's one of the other pieces there. Now, in logging, when you're writing code and writing games, one of the things we have to do is be mindful of the different language sets throughout the world. So you've got a difference between character streaming and byte streaming. Now, character stream is 2 bits, or 2 bytes, sorry, where a byte stream is a single byte. When we're writing data that's using the ASCII table, and the ASCII table, I think it's, if I remember correctly, it's 256 characters, or maybe 255. And the ASCII character table holds basically the English language characters, Romance languages. So anything that fits within that general group of characters will work. Now, if you start using foreign characters that go outside of that, things that are maybe Arabic or Chinese characters, there's not enough room in a 255 character table to hold all that information. So we have to use a Unicode format. Now, Unicode characters are 2 bytes each. And so using a character stream in code is a great way to ensure that you're getting and making the code compatible with different language types. And so there's a difference there in the way you stream that. And so in our code, we're using the character streaming to write out our files, our log files, our status reports, our inventory reports, and also the writes back to the console or to the end user's GUI or the graphical interface. So in our statuses view, we have this report writer, which we utilize. And this report writer, you'll see at the top here, we've got our print writer being called. This is for our status report. And then when you get down into the actual code, we're basically setting up our status report to use the new buffered writer, which is a control that comes with Java, and using also the file writer. And you see those controls are imported using the Java I/O import. And so I/O is for input output. That's the acronym for input output. And so we're utilizing the buffered writer and the file writer to update our report out to the report path, which we've established at the beginning of the game. Now, this true statement here represents that the file is eligible to be appended to. So we can add additional data to the existing report versus overwriting the report as it exists. So if I were to change it to false, it would simply just overwrite the report every time. Keeping it true allows it to update and append. Now we take the data that we want to write out, and again we're calling our status report, and we do a write statement, and then we write out the actual text. So this is just kind of a user text, but then we go ahead and pull a date and time function to write out the current date and time. So give it a timestamp, then we go pull the player name, and so we'll pull that from the temp user get player name, so calling that static reference there, and then temp map get difficulty. So you take basically the player name and the difficulty level and write that out. So in the game, the way to actually see that play out and write out to a file, let me show you that here. Set the play button on our game. And I'm going to go to the status area. So we'll start our game. I'll just hit G to start my game. And I'll put in my name as a captain, Captain Salim. And I'm going to pick hard. I want a challenge. And now here's where I go and pick my actual ship, and you'll see press 0 to select this ship. And the first one is a submersible. And then we have our ironclad, our galley, and our clipper. So I'm going to go with the ironclad here. So I'll pick 1, enter that. But now what I'm going to do is get to my statuses report. So I'll hit my view statuses. My view statuses shows me, okay, you've got a ship health of 20, my defense of 10, ship speed, current morale, the food quantities, water, coin, and lumber. Lumber being used to help repair your ship. The map that gets generated here will display to you where the ship currently sits. That's where you are. So that's the ship there. Your home island is also where we're sitting to start. So you don't see the letter H, but that's actually behind the S here. These stars that you see on the map represent storms throughout our map grid, and the O's represent all the different islands we want to try and navigate to find the various statues in the game. Okay, so to navigate across, we can use those controls. But right now I'm in the print status report, or I'm in the status view. I want to print this actual report to show you that aspect. So I hit P to print my report, and I'll go to my default menu, default directory, and open my status report. You'll see the timestamp, 3:25 a.m. Yes, I'm working late. It's been a long, busy week at work. I want to get this done. You'll notice my report is being appended, so I'm updating constantly, and we just basically have this status report here that's being written out into Notepad. And so you can add different things into the report. I personally like to always add a date and timestamp so you can kind of keep track of things. So we added that in even though that wasn't a requirement. Had a little fun adding that in. And then basically you can kind of go on playing the game. So I can go back to my game menu. Maybe I want to go look at the help, and I want to figure out what's the goal of the game. So I can hit G, get a description of the game. From here, I just hit enter, and then it comes back up again with the help menu, and then I can go, figure out how health works in the game. I can close out this menu and get into saving and loading the game. So this is where we're writing out the save and load information. So if I save the game, I can just go give it file path where I want to save the game, and then give it a name. So I'm just going to give it a name. Game's been saved. I can then also go into things like my inventory manager, loading the game, And then I can close this menu and get back to the actual playing board, where I can then board the ship. Now I board the ship. Well, now I'm on the ship. Now I have different options. I can kind of view my inventory, view my status. I'm going to launch the ship. We want to get to work. So I'm now launching the ship. It's now time to move. So now we're presented with directional controls. E for moving west, R for north, T to move east, and the 4, actually, sorry, the 4 is going to move north. The R is going to actually move you south. So basically, as a control now, I want to get to the various islands. Although I don't want to travel through storms because that may cause damage to my ship. So I'm going to start by going north. Just hit the R4. That moves my ship north. And now you'll see the exposed H, which is your home island. And you'll also see that the crew morale, the food and water will decrease with each move. Okay. So now the next place we want to go, we want to head over to the east. So we'll just go T, T, and then we want to go south. So we're going to go R. And now we're at a new island. You'll see it's utilizing food and water. So the objective for the user is to go in, make sure they're taking their coin, and when they get to each new island, purchase some food and water and try and befriend and find the statue from the local NPC. Now, in the interest of time, I'm not going to go through the entire game, but I wanted to give you a quick preview of how it works. It's been a fun semester. I've had a great teammate, which probably made it easier for me than anybody else in the class. Nathan did a tremendous job of not only being a good teammate, but also being a good mentor and a coach. And obviously, Brother Wester's contributions to the class were phenomenal. Everybody learned a lot through him and his enthusiasm for programming. So it was a challenging class, but I'm excited about what I've learned and appreciate all the teamwork from everybody in the class, and hope everybody's enjoyed my presentation. Thank you very much for your time, and have a great morning.